Okay, so I am still working on primarily getting the movement and attack radius mechanism working, and I think I had a little breakthrough on that off stream kind of late last night. And then I have actually spun off a side project for A-star pathing, which we may or may not integrate tonight, depending on how far we make it. So I guess let's just get back into that. This implementation right now, I guess, solved the problem, but it's incredibly poor, though conceptually sound. So I guess let's fix that first. So I banged that out in like 10 minutes once I realized what I needed to do. So let's see here. This is just debugging. This can come out. Also, I finally took a little bit of time to read the fine manual, at least parts of it, and found out if you start pick away from a console, you actually can debug output, so that makes this significantly easier. I guess we also need to implement a mechanism for tracking the cost of moving through the different tile types. That's probably on the agenda for tonight, because this won't accomplish anything productive if we don't do that. Oh, we have some efficiency to gain here. That's right. See if that got it. Nope. Method cached. Attempt to call method cached a table value. I mean, yeah, that's what I'm trying to do. That's the problem. 23. Attempt to call method cached a table value. What's the problem? Oh. So if you happen to see where we were last time, the problem we were having was that the recursive solution that we had implemented to solve this problem of generating movement radius functioned, but it worked very, very slowly. Like, you know, I think this is a radius of 10, what, 8 units. And to generate this before would take like a minute or something. It was totally unworkable. And when I read the fine manual and realized that you can debug output into a shell, that was what I needed to gain more visibility into what's happening. And what I realized is that the algorithm worked, but would revisit the same cell multiple times, and the function, I don't know if it was polynomial time or quadratic time or whatever, but we got into way too many function calls way too fast. And here, we can even blow this up again pretty quick, I think. If we take out this cached check, we can see exactly what I'm talking about. So this is gonna take forever and or out of memory. See, well, that's even not terrible, but it's bad though. And I mean, that's taken several seconds anyway. And I tried for a while to refactor away the recursion, because I generally think recursion is hard to reason about and use. But I found in this case, the iterative thing required so much more just tracking of state that it really wasn't worth it. But when I was able to debug how this thing was actually working, what I found is that I was revisiting cells multiple times, and at first I tried to cache some of those calls but failed, because the logic I'd implemented to cache was don't revisit any cell more than once. But that's actually not correct, and that's because this problem is actually tricky. We need to visit cells more than once, assuming that tiles will have different movement costs to traverse, which will be the case in our case here. Because a tile may be impossible to reach from one path, but possible to reach from another. So we might need to revisit cells to see if there are multiple ways to get to places. So the caching that I found that did work, though, is we can cache lookups on not XY cell coordinate values, but rather XY values, and also as a third dimension, the movement value that we had left when we got there. And that would take this lookup, like without this check, this lookup recurse like 20-something thousand times. And with the check, it's like 150 times or something. So that puts us in the realm of like no problem performance rise release. Like I hit the button. Oh, hang on. And now we loop infinitely. What did I just do? Did I not save this? I think I didn't save that. So you see how long that took to generate? Yeah, okay. I didn't reload. So now with a radius of 10, which we saw a second ago just took, 30 seconds or something to generate. Now I click the button and it's instantaneous. I'm not tracking how many, recursions are necessary here, but it's certainly orders of magnitude fewer. So that's great. And, we see here that the RAM consumption is, or like RAM and CPU is like 46, 47% or something. I think that is unfortunately just due to all of the drawing we have to do. Maybe there's room for optimization there, maybe there isn't, I don't know. But the good news is this is like a very, very big radius, and that's not going to be common for our game anyway. Probably we're going to have, a movement of like 5 or something. More commonly anyway, right? So anyway, that now seems to work, and now what we need to do is, I guess I shouldn't get ahead of myself. I think this works. The one thing that we are not doing currently is accounting for tiles that have a different movement cost. Right now, again, the cost of everything is 1. But I think this is going to be if this is right in my head, this should be a trivial change, where instead of subtracting 1 from our movement cost, when we recursively search a tile's neighbors, we just remove the cost that it took to traverse this cell that we're on, or something like that. So let's clean this up a little bit and commit this, and then work on something next. I don't know which I want to do. Maybe the tile cost thing, I guess. I guess we have to do the tile cost thing. Oh, I probably have all this A-star crap in here. Oh, no, I don't. Okay. I guess it's put map. Let's put our maps back to normal. Oh, and we also... Yeah, let's do this next, actually. Let's make our neighbor detection a little smarter. So you can see here, we'll visit cells that have negative coordinate values, and that's nonsensical in our application here. So let's fix that too, but we'll do that on the next commit. I have a ton of branches going here because, like I said, I spent a lot of time the last couple of days, like really digging into this A-star pathfinding stuff. I had planned initially to spin this stuff out into its own sub-project that I would open source, and I will probably still do that eventually, but I think I've decided there's enough complexity here that I want to use this myself for a while and make sure I've landed on the correct abstractions before I try to rip this out to open source it, because A-star, I'm new to it, but it's not particularly hard to understand, at least the big picture, but there's a lot of nuance to it, and I don't want to get it wrong if I'm gonna publish that for others to use, so I'll delay that for now. So this should be straightforward. This needs to be a little bit smarter. Do I have a cell? Okay, I have this. That might need to get smarter. I don't know. We can do that later. This, in that A-star spin-off thing, I fleshed out this cell class a little bit, and I might want to do that here too, but we'll do that later. So now here, we just need to... Actually, I don't like this name. Let's call that neighbors, because that is more accurate. And let's see, we don't want to produce cells with a negative value. So I guess we do something like this. Oh, do I... Let's see. I also need to know the width of the map. Do I have that? I kind of have it. This is gross. This isn't going to test well like that, so we'll make a note to refactor that later. I need to know the width, though, of the map, because there are 4-dimensional constraints. We don't want to go less than 0 in either X or Y, and we also don't want to go greater than the maximum of X or Y per the map dimensions, so we need to know what those dimensions are. And right now we're doing this kind of inelegant lookup on that value. We'll fix that later. So what's this going to be? Just a bunch of ugly conditional chains, probably. Okay, I'll do this the gross way. If x plus 1 is less than the width of the map, then add this guy. And if x minus 1 is greater than 0, add that guy. It's greater than or equal to 0, because 0 is valid. It's actually less than or equal. X plus 1 is less than or equal to the width of the map. Do x plus 1. X minus 1 is greater than or equal to 0. Do x minus 1. If y plus 1 is less than or equal to the height of the map, push it. And if y minus 1 is greater than or equal to 0, push it. See what that did for us. If we got it right, we shouldn't see any negative numbers. In our debug output. Let's walk this guy all the way to the other edge of the map too, and just make sure we handle all the boundaries correctly. And we've mostly solved the performance problem anyway with our caching, but this helps a little bit too because we aren't going to make a bunch of recursive calls on invalid cells anymore. Okay, I think that looks pretty good. Let's commit that. Okay. Am I wrong, or does that guy just not move the first time? 9 moves, okay. Let's see. Alright. So that all works. So now we need a mechanism for tracking the traversal cost of the different kinds of tiles. Probably just want an enum somewhere that maps like sprite IDs to the cost. I guess I could logically go in either map or cell. Maybe cell makes more sense. Just do this very straightforwardly. Cell cost is a map. And obviously none of this is like real currently, but like these sprites, I mean, we're gonna change all this. While we're regulating movement the way we are, I don't think I want any non-integer values for or do I? Maybe it doesn't matter. How's this gonna work? No, I can use floats. It's fine. So let's say the cost of, let's say sprites 1 and 49 is 1. And 33 is 0.5. And 17 and 18. I don't think I have access to positive infinity. Well, I want an infinity traversal cost for these. Let me check something. I thought I saw people on the Lua mailing list using 1 divided by 0 for infinity, which I'm sure that's mathematically correct, but I'm just skeptical of that for some reason. What's that going to do for us? I'm very surprised that works. I've never seen a programming language not just plainly fail if you do division by 0. Let's see. What did I do? Make Lua. What is 1 divided by 0? Print 1 divided by 0. Infinity. Okay, I guess that just does work in Lua. So there's our way to get infinity, I guess. Weird, but fine, whatever. So now we can look up our cell costs. Let's commit that. So we got that. I'll be right back. I'm gonna pour another drink here. Okay. So now, this is close to feature complete. I want to check something. This is stupid, but I'm annoyed by this orange color. I want blue. Let me just make sure we're handling our rivers correctly. Yeah, that looks good. Let's modify that sprite again real quick. Do I want a dark blue or a light? I had light blue before. It's not bad, but it makes our units kind of hard to spot or something. It looks a lot like black, though. Oh no, maybe that's fine. Yeah, let's do dark blue. That looks fine. I'll probably change all these sprites anyway eventually. I was thinking a little bit about the aesthetic I'm going to go for, and I don't think I'm going to go for much visual detail ultimately. One, because I'm not an artist, and two, because there are some meaningful constraints in what you can do in Pico 8. So I think I want the aesthetic to look like not pictures of tanks and stuff, but more like representations of units. And what I mean is, it's been a while since I've seen this, but if you remember like how they rendered units like in the what's that movie? The Orson Scott Card movie, Ender's Game, where they were just kind of geometric representations rather than actual, pictures of spaceships or whatever. I think I want to do that, so this will probably still look kind of abstract even when it's finished, but hopefully it'll look less, you know, less like it does right now. So, okay. Oh, so why am I using all these methods? I'm using append. What do we have here? We have search, append, neighbors, contains, clear, and draw. Yeah, those are all in use. Okay. And cached. Yeah. I'll move this dude down a little bit. Update. Yeah, looks alright. Okay. Commit that. Alright. So let's try this. I've renamed our cost struct to movement, just so I don't have a namespace conflict. I've created a cell cost method which accepts an XY coordinate and returns a value that corresponds with a coordinate. And then for radius search, what I want to do is when you arrive at a cell, hit our cache and potentially exit early, but if we make through the cache, look up the cost of the cell, and if the cost of that cell is greater than we have in movement points remaining, exit. Otherwise, deduct the cost of cell traversal and then proceed. I think that should do it, and if that worked, what we'll see here are no longer perfect radii, but we're going to see that the radius is a bit longer on the roads, or we're just going to crash. Okay. 26 function arguments expected. Oh. No? Wait. Oh. A damn colon. Every time. Is that right? Is that working? It's easier to think about if that value is smaller. Make that change. Let's change that map. Nerf this guy here. Speed is 2. So, that kind of looks right. So when he's on the grass, the forward and backward radius is 2. And then here he's burning 1 to get on the road, and then there's 2. And when he's on the road, it's 4. I think we actually got that right. Which is pretty cool. Yeah, okay, that's a great illustration. So backwards, his radius is 2 when he's in the grass. Forward, it is 4. Up, it's 4. Down, it's 4. I think we got it. That's actually... I'm kind of surprised how clean that is. That was really a bitch to think about. But I guess in the end... Once you solve all the recursion nonsense, it's not really that complicated. Yeah, that's cool. Okay. So let's clean this up. Let's unnerf this guy. And what? Need to comment some stuff we've done here. And I'm thinking... I spaced out there because I'm thinking about this Aura 1 thing. I don't know if I want Aura 1. I think I want... What does Lua have for, like, just throwing an error? My only hesitation here is that this is going to be a runtime error, because again, we don't have a compiler, I don't think, or we don't have compile time checking anyway or anything like we'd have in a grown-up language, so that's a little unfortunate. Maybe I don't know. I don't feel like thinking about this. We'll think about that later. This stuff all works, but again, there's going to be at least 1 or 2 more refactoring passes through this, so we can, like, especially when we go to write tests, because I still haven't written many tests at all for this. So we can answer these questions later and clean all this up. This is done. That I want to refactor. This is done. Yeah, okay. Get rid of our debugging. I'm pretty happy with all of that. Yeah. Make sure I didn't burn her down. Oh, and I want to look at this diff. I backed out. Yeah, I backed out the map change, right? Yeah, okay. So yeah, we get this guy on the road, and then he's got long movement. It's pretty cool. It's starting to feel like a real video game here. Very cool. So now, like, movement is solved, I think, like, completely solved. Now the thing we need to do, before we start to really look like a video game, is account for drawing the attack radii, which might require some modification on this. I don't think, you know, this radius code I'm not really planning to open source, I don't think, because, I mean, the whole game's gonna be open source, but I don't think I'm planning to extract this into a library, because I think this logic is probably too tightly coupled with my own game to be able to cleanly extract it. So with that being the case, I think we need to modify our loop to have like two sets of cells, and accept not only a movement parameter when searching that space, but also an attack range space. And then we simply stack one radius on the other, because see, it's a little tricky here now, because the movement logic works as intended, in that we have tile costs, but the attack range stuff will not have a tile cost. The range, the cost for attacking is always going to be 1 per cell, because you aren't really traversing the terrain, you're just firing a shot or whatever. So I don't know if we want to do that. If we want, yeah, I think we're gonna have to make the state tracking a little bit tricky internally to know if we are. But see, but I think I want to compute both radii in the same function call, because otherwise, yeah, like the movement cells are always strictly going to be a subset of the firing cells. So the latter are informed by the shape of the former. So they have to be handled at the same time. So yeah, there's going to be some kind of tricky state management in there. And I might think about that before I take a shot at implementing that, but I think that's going to be simpler, like probably markedly simpler than the problem we solved tonight. And then after that, once we get the firing radius stuff in place, then we can actually implement attacks and stuff, and we start to really look like a video game. The other thing we can do too is, so again, I'm not ready to publish this, but I do have this A-star tracking library working over here, and now that this works and is like kind of okay performance-wise, we can start to build an AI that actually thinks a bit. Right now all we have is a stub, and the units move back and forth pointlessly. But now there's going to be some intelligence in terms of them figuring out, you know, the price of moving anywhere. So then the last thing we need to have something that really resembles a game is just like a kind of a general, you know, enemy AI, and that's sort of what I've been looking forward to writing this whole time. So that should be a lot of fun, I think, working all that out. Did I commit this stuff? I didn't. Let's see. all this crap I have. Let's rebase master on this guy, because this is all pretty good work. Kind of hate that I have a bunch of trash branches here, but I was working really fast and loose trying to figure out the A-star stuff, because there was some complexity there. I'll ignore that for now. Let's see. Oh, and that's right, something else to account for. We wanted to change how we track how we track passable cells. We want to make a difference in tracking among cells that we cannot place a unit on but can pass through versus cells that we can't even pass through. And the big difference there again is like we want to be able to pass through tiles that we have our own unit sitting on, but we want enemies to block us. But of course we don't want to be able to stack two of our units on the same tile. So that's a change we gotta make, but I don't think that'll be all that hard. And then this stuff too is now effectively solved. The movement pathing arrow, that will just be A-star within the radius from the unit's current position to where the cursor is. So that becomes relatively trivial. And then the unit movement radius we solved tonight. This I'm not going to do. Animation and stuff all comes later. Yeah. Alright. Well, I want to think a bit before I implement this firing radius stuff. So I'll probably drop offline tonight, but thanks again for hanging out, guys. We're making some real progress. I guess have a Merry Christmas tomorrow if you celebrate, and I'll probably stream maybe tomorrow night or the next day or two, so I'll see you again soon. Have a good night, everyone. Thanks.